Let f is a function defined from r square to r by this formula. If the directional derivative of f at 0, 0 exists along the direction cos alpha I hat plus sin alpha j hat, where sin alpha is not equal to 0, then the value of cot alpha we have to find. So what is the meaning of directional derivative? Means if we are going to find directional derivative in all direction, or suppose we are going to or interested to find directional derivative at this point, so we are approaching like this. Means from all possible directions we are check directional derivative or derivative, but it is not possible from all direction because path may be like that. So we consider in direction, means like directed ray. So means in a unit vector it is not necessary we find directional derivative in direction of unit vector. Vector may be either unit or some other magnitude value, but some writer or examiner say we should take a unit vector because we have to restrict directional derivative at certain length or magnitude. So we have to find directional derivative in most of the case when vector is given in unit direction. Also, we have two types of formula. For existence, we use a limit concept, and if we are going to normally find the directional derivative, then del f with unit vector, dot product with unit vector, this will help you to find directional derivative and find at the point suppose AB. So it will give you directional derivative. And in the case of limit, when you are going to say that directional derivative is exist or not, so h tends to 0, f of c plus u h minus f of c divided by h. Or in other terms, this u is the unit vector, or in other words you can write limit h tends to 0 f of, suppose c is in terms of two coordinate system or xy coordinate system, suppose AB. So we have to write this AB plus U. What is U? Suppose constituent of U is U1 and U2. So U1H and U2H. This will be constituent of U. So we have to add them and minus F of AB divided by H. So in other words, you can use this concept also. So, but it is more convenient to remember limit h tends to 0, f of c plus uh minus fc divided by h. It is more convenient to remember this structure or formula. So we are going to find directional derivative at 0, 0. So value of c is 0 or origin. So limit h tends to 0. So f of 0, f at 0, 0 plus as a u vector or u vector is cos alpha I hat plus sin alpha j hat. So find its unit vector will be cos alpha I hat plus sin alpha j hat divided by its magnitude cos square alpha plus sin square. Value of this is identity 1. So this is the constituent of unit vector u, means cos alpha and sin alpha are the constituent. So you can write h cos alpha comma sin alpha, and you have to close this square bracket minus f of 0, 0 divided by h. So this is the limit concept. So this will be equal to limit h tends to 0 f of, now we have to add these. So f h cos alpha comma h sin alpha, and value of f00 will be 0 divided h. So this value we have to find limit h tends to 0, or you can write 1 upon h Function is 1 plus h cos alpha divided by h sin alpha. This is by the structure of f. You can see here f of xy is equal to 1 plus x upon y square when y is not equal to 0. So we obtain this value or structure or expression from the function. So h cancel out by h. So cos alpha upon sin alpha. Also the given condition is that sin alpha is not equal to 0. So you can see what is the importance of given condition as sin alpha is not equal to 0. So this is 1 plus cot alpha and this is 1 upon h and limit h is running from tending to 0. So 1 upon h, this is infinity, and if we obtain this as 0, so 0 into infinity, this is indeterminate type format, and we apply L'Hopital rule to find this limit. So it will only we can find when value of this expression, sorry, I circled completely, value of this expression as in red part means 1 plus cot alpha is 0. So this means that cot alpha is equal to minus 1. As we have to find the value of cot alpha, so value of cot alpha is minus 1.